Welcome to our first video on SLO7, the normal distribution. We'll be covering section 7.1, the standard normal curve. As I just implied, we will be looking at the normal distribution for the next several videos. Unlike the previous chapter where we looked at discrete distributions, binomial, discrete, the normal distribution is continuous. In fact, it's going to be one of the only continuous distributions we view and study, but it will be the most important that you'll probably ever see in the real world. Now, the way to think about how we get the normal distribution, it's just another frequency distribution, or really a relative frequency distribution, but it's smooth, right? Remember that the x-axis consisted of classes of, either groups or outcomes, right, numerical outcomes. The y-axis was the frequencies of each outcome, right? And now what we're going to imagine is that there are infinitely, in fact, uncountably many outcomes. And so what we have, remembering that bell curve that we looked at earlier, we have a bell-shaped curve that is unimodal, which means one mode. It is symmetric about that mode. The mean, median, and mode are all equal. It is infinitely wide, which is to say the domain of the curve is all real numbers, or you may have seen that written like this. And it is adherent to the empirical rule, which means the following, that we should remember from before, right? 68% of the data is within one standard deviation of the mean, 95% is within two, almost all of the data, 99.7%, is within 3 standard deviations of the mean. That applies to the normal distribution. Now, since it is the graph of a frequency distribution, we can use the curve to infer proportions of a population. Same way we could with other graphs, and that's a lot of what we're going to do this section and the next section. Right, so for example, if we look at this curve right here, what does the shaded area represent? Well, if the area is 0.16, right, that means that the shaded area represents 16% of the population. Right, which means that 16% of the population satisfies values 4 to 6. Like, whatever you're measuring, 16% of the population is between 4 to 6. Okay? Now, one cool thing is that the normal curve is determined entirely by its mean and standard deviation. Which means we can accurately estimate proportions of populations just by knowing z-scores. Right? Remember we did z-scores a couple of SLOs ago? Right? So what we're going to do to find the standard normal curve is we take each raw score, x, of a normal curve, and we turn it into a z-score by applying the z-score formula. Remember, to turn a value x into its z-score, we say that z equals x minus the, I'll use the mean, divided by the standard deviation. Or if we're using sample data, then we write it this way. It's the same thing, we just use different variables, right? And so the resulting curve is called the standard. When you do this, when you take every single data point and transform it into its z-score, then you have something called the standard normal curve, whose values on the x-scores are z-scores. The standard normal curve has mean, pause the video and try to get this, 0, and standard deviation 1. Why is this? Well, because the mean of any data, of a normal data set, has a standard deviation, or sorry, rephrase that. The mean of any normal curve is 0 standard deviations from itself, and so it always has z-score 0. So the mean of the standard normal curve is the z-score of the mean, which is 0. Standard deviations are 1 just by definition, right? So this is the standard normal curve, right? This is a normal curve with mean 0 and standard deviation 1. So just note that 68% of the data will be within this blue region, 95% of the data is within this red region, and then, of course, 99.7% of the data is within this green region right here. But again, just to point out, the mean equals 0 and the standard deviation equals 1. Okay. Hope that's clear. Okay. Moving on. Let's look at the following standard normal curves. So then the question is, what proportion of the population are within the shaded regions, right? So we know that the total area under the curve is 1 by definition, right? So let's just note that. All right. So for these guys, there are two ways to do this. We can use the charts from the book, or we can use Minitab. I will always let you use both. I will pass out charts whenever you're giving an assessment on this. So let's first use the charts from the book, because it's good to be able to do this. Now, if we want to use charts from the book, we go to our My Classes page. Apparently there are some people who didn't even realize we had a book. We do. And you just click the book icon right here. And voila, there's the book. So you're going to go here, table of contents, go all the way down to the appendices. Let's try Appendix A, tables. Oh, no, sorry, actually, I'll do better than that. Tables A2 and A3. That should do it for us. Yeah, I think it's got, yeah, right over here. These are the tables we're going to use. So on assessments, I will print these out and give them to you. Right, not that. We're going to use table A2, okay? So if we look at our notes, I just put them over here real quick. Oops, I did not mean to do that. There we go. So you see that this is a standard normal curve. We've got a z-score of 1.25, and we want to know how much area is to the left of that. Well, note that we have a corresponding picture right here. Right? So what we do is we want to find the z-score 1.25. So we look on the left-hand side. See that 1.2 right here? That's what we start with. And then we look in, we just sort of go to the right? We're going to look in this row. And if you look way up here, right, we go 0.0, 0.1, 0.2, 0.03, 0.4, 0.05. So we go to the 1.2 row and then the 0.05 column. That's going to give us the number that we want. So let's see where we are. 1.2, right here. Okay. So let's see. 0, 1, 2, 3, 4... 1.25, right there. Okay? So just using the table, do not want to do that. Let me just move it over here and just try to zoom out of this guy. There we go. So here we can say that maybe I'll shift it over here. .8944 of the data is to the left of, or maybe I should say, has z-score less than, or you can write less than or equal to, it's the same thing. Okay. Now, what about this case, right? How much data is to the right of 0.36? Now, this is a little bit more work, right, with the chart, right? Because the chart always gives us stuff to the left, right? It doesn't give us stuff to the right, right? And then this is another chart. Do not use this chart. It is for a different distribution. So what we have to do is just a little bit more work, just a little basic subtraction, right? We're using complements here. We find 0.36, right? This is 0.3. 0, 1, 2, 3, 4, 5, 6. Aha. 0.6406. So let me just go in here. 0.6406 of the data is to the right of z equals 0.36. So 1 minus 0.6406, which equals 0.3594, I believe. Is that right? Yeah, I think that's right. Is to the left. I meant to say left over here. So this amount is to the right. Okay, so we just use basic complements here, right? Now I'm going to use Minitab. Let's try to remember our numbers here. Let's go to Minitab, open it up, and we are going to go to Graph, Probability Distribution Plot, View Probability. Make sure the distribution is set at normal. We're going to keep the mean at 0, standard deviation at 1, and we're going to go to Options. And at this point, we want to choose Specified X Value. I know we're talking about Z's, but just they call it X right now. Now, for the first one, we want to make sure that we've chosen left tail because we want to find the area left of our value. And our value is 0.125. And sure enough, 0.8944, just like we had before. Now, for the other example, again, graph, probability distribution plot, view probability, options. Now we want to do right tail, and we want to choose the value 0.36. Press OK. And sure enough, 0.3594. Okay. So let's just get both of these guys, screenshot them. And then we're just going to paste them over here. So you see, you can use whichever way you want. Minitab, kind of a bit easier, I think. Oh, oops, I did not want to copy that. I wanted to crop it. My bad. But it's totally up to you which one you want to use. Let's just take a sec to crop this guy, and then we're going to move on. Right. But the point is that no matter how you do it, you should get the same answer. Now, here's another example. Find the z-score in the 80th percentile of the standard normal curve. So for this one, again, I'm going to show you how to use both techniques. Remember, we're looking at the 80th percentile, okay? So if we go back to our chart, which is right here, our table, right? all we want to do is we want to just use our eye and look for the value closest to 0.8, right? 0.80, right? That's 80%. So it looks like we're between 0.80, 1, 2, 3, 4, 5. So it looks like it's about 0.8, z equals 0.84. Okay, right there. Now we can get a more precise answer using Minitab. Right, so let's see what we get here. Here, let's get rid of the navigator. We're going to go to graph, probability distribution plot, view probability. Keep that the same, but now we do want a specified probability. And here we're going to enter 0.8, right, because we're looking for 80%. And actually, one sec, I want to make sure I got it right. Yeah, 80th percentile. Okay, so we're good to go. So we want to make sure left tail is selected. Very important to select left tail. And voila. So you see 0.8416, right? So we get a slightly better answer in this case. Slightly more precise using Minitab. And it didn't really take that much longer. Probably a little easier to use the table in the book, but you should be able to do both. All right, so we've got this right here. So now let's continue, right? Just a couple more examples, right? We looked at the area to the left of a z-score, to the right of a z-score, but suppose we want to find the proportion between certain z-scores, right? Suppose we have a situation like this, right? We've got a normal curve. It's my best attempt at the standard normal curve. And suppose this is our mean, right? This is our mean equals 0. And suppose we want to find the proportion of the population between, maybe I should just draw, let's just make this solid, right? Negative 0.34 and right here, which is 1.12, right? So I want to find the proportion of the population, or how much area is under this curve between these two values, right? Now, you can use the z-table. Frankly, for this, I'm just going to use Minitab because I think it's easier. We go to Minitab, graph, probability distribution plot, view probability, options, and we're going to do specified x value, and look, we're just going to do middle. X value 1, negative 0.34. X value 2, 1.12. Okay, and that's our answer. So a little over 50% of the population is, there we go. A little over 50% of the population is between those two z values. So let me just circle that really quickly. So 0.5017 of the population is within the interval negative 0.34 to 1.12. And then last, let's do one more example, right? Find the z-score such that 72% of the area underneath the curve is between negative z and z. So again, let me try to draw the normal curve, standard normal curve, something like that. Again, this is our mean, which we know equals 0. And the idea is that we're trying to find negative capital Z and positive capital Z, such that this area right here is 72%, right? Now, there is a reasonably straightforward way to do this using the table, right? You can just note that, well, this is symmetric, right? So that means that there's 20% of the data outside the curve, right? So there's like, divide that by 2, right? There's 14% here, 14% here, and you can just say, oh, look, this is the z where value where there is greater than 86% of the data, and you can just look it up. Or what you could just, so like using the table is not so bad, or what you can just do is use Minitab, which I'm going to do, graph, probability distribution plot, view probability, options, and we are going to do specified probability. Wait, this one, let me see how we do this one. Actually, I think we want to just do equal tails for this one, actually. Now, equal tails for this one, and we just want to be a little careful. Note that they have P2 and P2 right there, or P over 2 and P over 2. So I believe what they want us to say here is 0.28. It's the outside probability. So let's see what they give us right here. Oh, that's 14, yeah. So you see how it gives us that z-score 1.080? That's going to be our answer. So maybe that was a little involved using Minitab. All right. And let's just paste this real quick. And that's our answer. And that's what we've got.